My name is and my group member is Shafi, and we are here for the project of slope stabilization in Sargodha Hills, Kirana Hills. And you can see this is a project. This is a statement which is assigned to us. These are the hills where the laborers are working with ropes and doing blasting for mining purposes. These are some objectives used. Let me show you some objectives. We have to assess the site and report on overall stability of the mining area. So introduction is given, and these are some of the requirements for doing the slope stability test. So now we will move forward towards the formation of sandstone. The formation of sandstone or Kira limestone is a Kira sandstone, and these are some of the properties determined from the various research papers and the laboratory tests. Now the using of these properties will further be explained by my group member, and she'll tell you about how to use RockLab software and how to create the dip software.
Assalamualaikum, my name is Asma and I will tell you how to use RockLab software. Here are some estimated properties of sandstone. We will put it in the RockLab and find roughness properties. Here is the RockLab. We will put 43. UCS and GSI is given, which is 68, and mass of sandstone is okay. Modulus is 2000 megapascal. Disturbance factor we will put 1 because there is continuous blasting. And here are the properties, rock mass properties, Hochbrand classification, Hochbrand criteria, Mohr column and rock mass parameters. Here are the dip and dip direction of the different joint sets. We will plot manually. Here is the view of the stereonet which we plot in the butter paper. I will plot it on the dip software and then verify it. I copied the points there. I will use the vector preset point. Here is the points concentration. You can use dip vector mode to change the direction or concentration. Here are the direction concentration of the points. We can plot the planes here. Here is the concentration of the points which will tell about the joint set numbers. 1, 2 and 3 are the joint set numbers which are more visible and having more concentration. I will go to the information. Here is the trend and plunge of the joint set numbers. There are 3 joint set numbers. Their cohesion is given 1.786, which is given.
So my group member told you about the dip software and RockLab software. Now I'll tell you about the usage of S-wedge for surface wedge and the phase 2D for stabilization purposes. As you can see, we have done the softwares and we have this data. Now for Swiss software, I'll open the Swiss software and create a new file. In doing input data properties, I will do the input data, and as you know, we have the joint sets dip 2 and joint 281. Second joint set we have got 88 and 151 dip direction, and the cohesion is 1.786 for both of the joints. As you can see, the friction angle here is 30 degree because the friction angle is calculated for sandstone. The upper face is not present, so we will put 0 for it, and the slope face we have calculated 60 and 194. As you have seen, there is no tension crack, so we will uncheck it, and the slope height is maximum 30 meters and unit weight is 2.6. So we will apply it, and you can see here we have got the wedge failure from top view, front view, side view, and here is the perspective mode You can see it from various sides. Now we can also see the stereo net. You can see there are various stereo net. Here is a plane where is failure happening. Now moving towards the Phase 2D softwares. Here's the Phase 2D software. First of all, we have to go to point origin, and there's a problem here. Now we will add external boundary, and we can make a slope as we want. Just several slopes, and this is like a material. We can change its material properties. We can add sandstone here because we are doing work in sandstone. Now we have to add some joints. As you know, we have 3 joints, so we'll add some joints here, and then add joint again. Now name joint 2. Make it joint 2 and make it like this. Now we have to do the joint 3 because we have got 3 joint sets here. You can mark the joint 3 here. After doing this, we have to create mesh, like the size of the mesh, graded mesh, and here we got mesh. So we have to remove these points from restraint from boundary because it's free slow phase. As you can see, I can click on it and right click, free restraint, slow phase is free. So we are here and calculating the slow phase. Now we will do the computation of results. So we have to save the project. Now name it some project 1. Now save it. So now after computation, when we say interpret, you can see the software can tell us where the maximum numbers of stresses are, where the stresses are maximum and where the stresses are minimum. So where the stresses are maximum and where the stresses minimum. So in this way, we have calculated the stability using Phase 2D software and put it here. Thank you. My name is Sayyid Hamadul Hassan.
And my name is Asma Shafiq.
Now we have completed the project on Sandstone in Sargodha Hills. So as a mining engineer, here are some recommendations we recommend for the project. The slope should be, the failure should not induce because it's not safe for the workers, and as well the blasting should be controlled there. There should be no uncontrolled blasting as it can lead us to serious hazard. Moreover, we can make a design of open pit mine, and also we can suggest a small quarry for surface, but the mining method unconventional which is being used there is not recommended and not encouraged, so they should use the conventional mining method. These are other recommendations about the project. Thank you.